so we'll go ahead and start our last talk. Colton Palmer is going to tell us about an analysis of hydrocarbon production potential using some well data.
So I analyzed hydrocarbon production potential using well data from southern Garfield County, Oklahoma. My study area was in north central Oklahoma, Garfield County, which is this little pink area. And so Oklahoma is divided into townships. Each township represents a 6 by 6 mile area, and each township consists of 36 sections. And so a section is just a mile by a mile. And the area that I focused on was down here, this red box. That's township 20 north, range 5 west. So hydrocarbon production in this area has been pretty extensive. They produce from the Mississippi Oswego and the Chester limestones, the Cleveland, Red Fork, the Meisner, and the Skinner sandstones. However, some areas could have been overlooked, and when I say overlooked, I don't mean that they just walked by them. I'm just saying that maybe at the time it wasn't technologically feasible or not economic to extract the hydrocarbons. And so I primarily use well logs to search for what I call new oil in old fields. And so a well log gives us a detailed representation of subsurface geologic formations. And so they attach this tool right here to a cable and they lower it down. And as they're pulling it back up, depending on what type of log we have or log tool, it sends us data relevant to what type of tool it is about the surrounding rock. And this is what a log header looks like. It's pretty basic information. It can tell us company, well name, field, county, location. And then these abbreviations right here will tell us elevation at the surface where our derrick is. And then all this information is just other basic stuff, viscosity, temperature, porosity, all that. So the types of wells that I used during my research was the gamma ray resistivity, caliper, neutron density, and the SP, spontaneous potential. There's other types of logs, but this is the data I had and the logs I had, so that's what I went with. The gamma ray measures the natural radioactivity of rocks, potassium, uranium, thorium, or some naturally occurring radioactive elements. And so with the gamma ray, we usually, like through this zone right here, it'll tell us shale content. And as we move down throughout here, as it kicks back to the left, that's going to be a more clean rock, not radioactive. And so we measure that using API units, which is American Petroleum Institute. The caliper is a pretty basic log. It records the diameter of the borehole. So they drop it down the same way they did in the picture. And it has 2 prongs that stick out, and they slide up the side of the hole, and they can detect any dissolution or falling rock in the borehole. And in turn, this affects the quality of our other logs. It'll send us irregular readings in our other logs. And so, for example, down here, it looks like there could be maybe some dissolution or something going on there. And we just measure it in inches, pretty basic. The spontaneous potential log measures the electrical potential between depths in the borehole and the surface. So our higher clay content rocks will generate 1 charge, and our permeable rocks will generate another charge. So this is the SP curve right here, and up here we have our high clay content rock. As we move down, it gets to some more permeable rock. And we measure that using millivolts. The resistivity measures the ability of rocks to conduct electrical current. And so the shallow, medium, and deep is the distance from the borehole that's penetrated by the current. And so the one that they look at the most is the deep, because it's probably undisturbed by the drilling process, which we have some mud filtrate in there that can flow out and disturb the shallow and the medium. And so saltwater will have a low resistivity and hydrocarbons high. Resistivity we measure in ohm meters. And then our neutron density, which are porosity logs. The neutron measures the amounts of hydrogen present in water atoms and also in hydrocarbon atoms. So basically it just bombards the formation with neutrons, and depending on what we get back, it will tell us the porosity. And so density will in turn emits gamma radiation, which is also sent back to the detector. Higher gamma ray reflected, greater porosity. So we get both those measurements in calculated in percentages. That tells us our porosity percentage. So the difference between porosity and permeability, porosity is just the void space in the material, and permeability is the quality of the material that allows gases and liquids to flow through it. So basically, permeability represents more the migration of oil fluids. So what's the purpose of all these logs? Well, they can tell us quite a few different things. Lithologies, rock type, rock composition, the depth of the formation, elevation, thicknesses, resistivity, porosity, and then we can eventually get some values and calculate water saturation, which will actually tell us how much water we have versus how much oil. And so this is a pretty important equation. It's Archie's equation of water saturation. And so we get our values from the logs like porosity or true resistivity, and we plug them into this equation, and it gives us our water saturation. So this is a map that I constructed in Petra, which is a computer software. It's a pretty basic map. These little green dots represent oil wells and clear, spiky ones, gas wells. And so these lines that go through here represent horizontal drilling. And so say they spud from this point, which is where they drilled. They horizontally drilled out from this point to this point is where they ended in the same diagram. And so this is an oil production map. All these colors represent formations in the subsurface. For example, this dark blue over here represents our Skinner sandstone. So we can see the Skinner down here, this dark blue over here. And so I zoomed in on this section just so it's not as confusing. If we look back, we can see the Skinners here, those three wells we were just looking at. And so this is an initial production map of our oil volume. We can see, looking back at the Skinners, we had 23 barrels per day, 40, and then if we look down here, we had 517, which is really good, and that's that horizontal well that they drilled that I was just talking about. So that horizontal well they drilled there. And then this is the gas volume, initial production gas volume. Looking back at the Skinner, we had 110. That's actually 1,000 cubic feet of gas. I know it's an M. Kind of made me mad also. It should be million cubic feet. Because billion cubic feet is actually a B. So yeah, I don't know why they made that. Anyways, yeah, so it's 110,000 cubic feet of gas. And so the areas that I was kind of looking at were these areas here. Either there was no wells or I didn't have the data, just kind of depended. So that's kind of what I went through and I was looking at. So I plotted all the wells in my township on my own on this piece of paper. It took me forever. Yeah. And so this kind of just gave me a better idea of what was going on in the area, the formations, what was producing, what wasn't, how much, and that. So this is the same map produced throughout my township. And so this is an example of cross-section that I constructed. We use these cross-sections a lot when correlating formations. So this area right here is where I was focused on. It's the southern part of my township. This is section 29 through 26. Point A to B represents a 3.5 mile cross-section. So this top red line represents right here is the top of my Oswego. The bottom is the bottom of the Oswego. And so as we move from west to east, we can see that there's an elevation change. And my interpretation of that was that the shelf, the carbonate shelf where these limestones were being deposited was getting shallow. And so one other thing I saw was a thickness change. We had 150 feet down here and then 210 feet up here. I thought that was pretty interesting. And then this is a structure map of the Oswego limestone that I made in Petra also. It's pretty similar to a topographic map, except it shows us subsurface topography. Same area that I was looking at with my cross section, and we can see here that there's an elevation change, just like I saw from west to east, just like I saw in the cross section. So I took some values for Archie's. I went ahead. We can use all this geologic information but it doesn't really mean anything if we don't find oil or if we don't need to look for it. So I was looking for some oil using Archie's equation. For example, this section here, there was already some values that they had from the 80s, and I went ahead and plugged those values into this equation here, and I came out with 40% water saturation. And I just went back through and checked, got my own values, and it was pretty much the same until I got to the true resistivity, which is over here. And they had calculated 18%, or 18, and I had calculated 28. So I took 28 and I plugged it in, and I ended up getting 31%, which is almost 10% better, so 10% more oil in that little section right there. So other potential analytical methods that we can use are isopack maps, which tell us thickness. I'm still working on that one. Seismic data interpretation. I don't have access to that, but that's another tool. Calculating hydrocarbon reserves and volumetrics, and then economics. So I spent a lot of time trying to find, some areas that we could go back into and search for hydrocarbons. But it's risky because we don't know for sure. I mean, I can't tell you 100% that what I've studied is automatic. So not just for me, but for any oil company that wants to do what I'm doing. So, but in return, we can get a lot of money. That's a good thing. So at a low price, we'll take 3 barrels per day, which is what we had in the Skinner. And at the current price right now, we have it $41, $90 per month, about $3,700 a month, which ends up being like $45,000 a year, which isn't horrible, but on the high side, at $110, calculate that out, we get almost $120,000 just from 3 barrels per day. So that's pretty good. But what did I find? Nothing. So I spent a lot of time, and it's unfortunate that I haven't found anything yet, but I focused on a small area. There's just in the township, a small area, and so there's the whole rest of the township and the whole rest of Garfield County that I could go through and look at. And I'm still working on it. It's an ongoing process, so I'm not done with it. So I'll still continue to search for riches. And then, this graph shows rock beater quality versus oil production. Our oil production runs through here, and it's getting higher, and our popular rock music is doing really well. Does anybody know what this is right here? What? It's 1957, 55.
That's Buddy Holly.
Buddy Holly. And I think it's Elvis. Yeah. And then I think this is the Beatles over here.
Yeah, that's the Beatles.
There's a Led Zeppelin peak.
So obviously we need better rock music in order. We need better rock music in order for our production. So. Any questions?
How did you get your well log data? Did you actually take that data, or is this already existing data that you're analyzing?
Yeah, this data is from like the 80s, most of it, and it's stuff that we got sent to us, or we already had. I think Dr. Walsh had it already. I just took that data and analyzed it. I analyzed the data in the well log to look at what I've been looking at.
I guess it kind of negates my question, but I was going to ask, is it necessary to use all of the different well logs if like some of them seem a lot more effective than others for determining like the quality of the rocks or running oil?
Not really. What they do is they stick, like, say we have our well log or our cable, they stick all the logs on one thing. So you'll have your gamma ray, your SP, and they stick it down. So it really doesn't matter. It's not like they have to pull it back out, attach another tool, send it back down. You can do them all at the same time. So, I mean, why not do them all?
Yeah.
Give us a better idea.
So your values for your Archie's equation, did you pick those yourself? Like, I know you said you went back. Did you pick those from paper logs, or was the data that you had, was it already from like a digital LMS file or something like that?
Well, it's actually what was written on the log.
Okay.
Yeah, so I went through and I did their numbers first, and then I went back through and just checked their numbers. And for the most part, I had the same numbers until I got to the true resistivity, where I had 28 and they had 18.
Right. And did you pick these for most of Well, how did you come across the formations you wanted to focus on? Just by their production values, or?
Yeah, well, the Skinner, I looked at the Skinner, that was the one that was in the log. I kind of just went through and picked it, and I picked that top. And actually, nobody's produced from that zone yet, so that's a possible explanation of what I've been doing, but I don't know for sure.
So you didn't use the other formation numbers?
Yeah, no, that was just the Skinner, yeah.
Okay.
With this graph right here, in the last 10, 15 years, we're not going to know if any of those songs are great until another 20 years from now, right?
Yeah, or
So-
somebody.
So that might grow. Maybe somebody.
Yeah, well, it grows a
decide-
little bit, because we already know that, because 2007, yeah, so there was a little spike in there.
I think rock music quality is represented by like, I think it's represented by like how many people like the song, which pop music is like EDM
But this is-
popular right now.
Songs in Rolling Stone's 500 greatest song of all time list. So we're not going to know that.
I think it's interesting how the Beatles effect lasted longer than Buddy Holly effect
So we need to make more good music if we want oil production.
Exactly.
Or is it the
So
other
we
way
have to
around?
get more songs into
No,
it.
see how
Where's
it's
this come from?
sloped a little bit, or it's skewed. The peaks are a little off.
Any other science questions?
I have
More comments?
I have more about the logs. What log did you use to do your correlations with, like your cross sections?
I use all of them. Yeah, so I had my SP in there and gamma ray and resistivity. I didn't really focus on like a caliper or something like that. But when I'm correlating them across, I used the resistivity and the induction logs on the left side, and then I went through the gamma rays and all that.
You have any other questions?